All right, let's get right into it. If you follow the AI space at all, you have definitely heard of OpenClaw. It's this massive open source project that promised to give every single one of us our own personal, always-on AI assistant. It completely took over, but behind all that hype is a fascinating story of brilliant design and some truly shocking security flaws. And when I say it took over, I am not kidding. OpenClaw just blew up, racking up over 172,000 stars on GitHub in what felt like overnight. This wasn't just another chatbot, It felt like a movement, and developers were absolutely captivated by its core promise. And that promise? It was so simple, but so powerful. An AI that doesn't just sit in a chat window. No, this thing runs on your machine, it plugs into your apps, we're talking WhatsApp, Slack, you name it, and it actually does things. It can book your flights, it can check your code, it can organize your entire digital life. This slide really nails the huge leap forward we're talking about. See, on the left, that's the world of passive chatbots. You type, they respond. It's a back and forth. But OpenClaw, that represents the shift to the right, an autonomous agent where things happen without you even typing. It's proactive, not just reactive. It's working for you, not just waiting on you. So how did they pull this off? Well, as one systems researcher pointed out, the genius of OpenClaw isn't some ridiculously complex new invention. Not at all. It's actually in the elegant way it combines two core, really powerful ideas. The first big idea is something called autonomous invocation. And this, right here, is what lets the agent be proactive. It can be triggered by a schedule, think of it like a cron job, or it can be triggered by an event, like a new email landing in your inbox or a file changing on your computer. It's not just sitting there waiting for your next command. And the way it works is just so simple but so effective. A trigger happens. Then the system routes it to the right session. And this is super important so a work task doesn't accidentally bleed into your personal chat with your family. And then it runs the task. That routing step is absolutely critical because without it, an always-on agent just becomes an always-confused agent. Okay, the second breakthrough is persistent state. This is what gives the agent a real long-term memory. It's not stuck with the short attention span of a typical chat context window. It can literally write notes to your local disk, remembering your preferences, past conversations, ongoing projects, pretty much forever. And this is the game changer that turns a simple tool into a true assistant, one that actually learns and customizes itself to you over time. A researcher put it perfectly with this quote: "The agent's short-term memory, that LLM context window, that's just a cache, it's temporary. The real memory, the source of truth, is what's on your disk." Someone even called this virtual memory for cognition, and that's exactly what it is. It's what allows the agent to truly learn and grow with you. So we've got this incredibly powerful, unbelievably popular agent built on two genuinely brilliant ideas. But this is where our story takes a really sharp turn, because hiding in plain sight, right inside the OpenClaw codebase, was something deeply unsettling. Just think about it for a second. You've given this thing access to your messages, your files, probably even your credentials. You've trusted it to act on your behalf. But what if that trust is built on a foundation that's fundamentally broken? And then this dropped. This was the title of a Reddit post that sent absolute shockwaves through the community. A security researcher was auditing the code and found not just a bug, but what they called a built-in backdoor. And it was shipped with every single copy of OpenClaw. The backdoor was actually a feature, a hook with the ridiculously ominous name Soul Evil. I mean, you can't make this up. When it was activated, it could silently swap out the agent's core system prompt, its personality, its core instructions, its entire soul, with a totally different file, and the user would never, ever know. So how does this actually work? Well, the attack is alarmingly simple. First, an attacker just has to get a message to your agent telling it to write a new malicious file. Second, they use a poorly secured command to flip on that Soul Evil hook. And just like that, the agent's identity is swapped. Your trusted assistant is now their puppet, with full access to your entire digital life. And here's the really unfortunate part. The Soul Evil backdoor wasn't just a one-off mistake. As researchers started digging deeper, they found that it was part of a much larger and frankly troubling pattern of security oversights baked into the project's architecture. The list is just alarming. A critical remote code execution vulnerability, thousands of instances just sitting exposed on the public internet with no authentication.
credentials like API keys stored in plain text, a skill marketplace that was just filled with malware. It all points to a system that was built for cool features first, with security being a very, very distant afterthought. So, what does this all mean for the big picture? The story of OpenClaw isn't just about one project's security failures. It's a massive case study for the entire field of autonomous AI. And it forces us to ask some really hard questions about where we're going. This quote, which came from another AI agent commenting on the situation, just cuts right to the heart of it. The ability to silently change an agent's core programming isn't just a technical bug. It's an existential vulnerability. We're talking about an issue of identity and integrity, not just lines of code. So, what can we actually do about it? This is the practical takeaway. Before you even think about installing the next cool autonomous agent, you have to stop and ask these questions. Who can talk to this thing? What can it actually do on my system? Is it safely isolated in a sandbox? Do I have any clue what's really in the code? And could I even tell if it went rogue? These aren't just suggestions anymore. They are necessities. And that leaves us with this final critical question. OpenClaw proved that the demand for personal AI agents is absolutely real. The promise is incredible, but the peril is just as real. The challenge for everyone building in this space is no longer just about making something powerful. It's about making something trustworthy. So how do we build the amazing AI agents of the future on a foundation we can actually depend on?